Hello guys, welcome to our video of series called C# for Beginners. So today's lesson is a bit of grab bag, several genuinely useful C# features that don't quite fit into classes or collections cleanly, but that you'll run into constantly once you start reading and writing a real code. Let's start with a problem. Say we want a method that returns two pieces of information at once, like a person's name and then maybe their age, without creating a whole class just for that. Think about it for a second. Every method we have written so far returns exactly one value. What if we genuinely need two or three without the overhead of building a dedicated class just to carry them? This is exactly the kind of problem today's first topic, Tuples, was built to solve. So let's dig in. Parenthesis string comma int and closing parenthesis person equals parenthesis Alex and comma 25, right? This creates a tuple, a lightweight temporary bundle holding two values together, a string and an integer, without needing any class at all. So let's run person.item1 item2. Okay. And to access each piece by default, we use .item1 for the first value and .item2 for the second. Genuinely usable, but honestly not the most readable names. Tuples let us group a few related values together instantly without any ceremony, but those generic item1, item2 names are a real weak point. Which brings us to the next topic. Next thing is we can name it something like string name int age, maybe. Same idea, but this time string name and then int age. Right inside the parentheses, we are giving each position an actual meaningful name. And here also name and age. Okay. And now instead of item 1 and item 2, we can access them by those meaningful names, .name or .age. Genuinely reads so much so clearly, right? And even shorter way to write is something like that. Maybe var person equals name, oops, name Sam, and then age, maybe 25. Console.writeLine person dot maybe name. And combined with var, we can skip declaring the type explicitly altogether. C# infers it from the values we provide, right there in the assignment, right? Named tuple elements are genuinely the versions you'll use most in real code. Same lightweight bundling, but with the names that actually tell you what each piece means. Now let's actually solve our code open problem, a method returning a multiple values, right? So let me create some methods, maybe int, maybe min, int max, get min max, and then we're gonna have list of integers, numbers, parentheses and int min comma int max, and we're closing it. That's our return type now. Name it a tuple instead of just one plain type like int or string, right? And then inside our function, we're gonna get int minimum with maybe numbers dot min int max. Right. Remember min and max from the LinQ lesson. We calculate both and return them together as a tuple, matching the names we declare in the method signature, right? And then let's get actually values, for example list int maybe scores equals new list 5 92 78 5 and then maybe 88, right? And then var result equals get min max, and then scores, right? Console dot writeLine min result dot min max result dot max. And calling it, we get back a single tuple and access both pieces by their meaningful names like min or max, right? This is generally the most common real-world use for tuples, returning 2 or 3 small related values from a method without needing to define a whole class just for that single purpose. So let's see the output with running the code, right? I hope you are seeing the terminal, right? Oops. Okay. Okay. .NET run. And as you can see, minimum is 78 and maximum is 95. Now there's an even cleaner way to grab those values out. That's called deconstruction of tuples. Let me show you. It's gonna look like something like that. Var min and max equal get min max scores. Okay, and here get min max scores, instead of just getting back one tuple variable and reaching it into with dot min and dot max, we are immediately splitting it apart into two separate standalone variables, min and max, in one line. So in order to just print them, we use their min itself and the console dot writeLine max itself. Just delete that for now, and then let's see the output. As you can see, 78 and 95. That's actually works on regular variables too, not just tuples, right? And maybe let me show one example. Whenever you are just creating a variable, if you know, whenever you are creating some kind of variables, for example, you need some 3 or 4 variables, like for example int a equals some kind of value, int b equals some kind of value, something like that, right? So you need a lot of lines to create a few variables, but you can do it all of them in one line using the tuples like that. Int x, int y equals just 10 and 20. Done. Console.writeLine x, console.writeLine y. Okay, just delete all of them and let's see outputs. Okay, you can deconstruct a plain inline tuple the exact same way, useful for quickly assigning several values in one line and creating new variables like. And deconstruction is genuinely just a convenience. It saves you from writing results.min or result.max repeatedly by splitting the tuple apart immediately into a clean individual variable. Alright, next topic is actually somewhat related to tuples. What if you want to bundle several values together with names but genuinely don't want bother declaring a type at all, even a tuple type? Let me show you. For example, we have a var product equals new name equal laptop, and then we're gonna have maybe price equals 1000, and then in stock equals true. Right. Var product equals new curly braces name equals laptop and price equals 1200 and in stock equals true, right? Notice a new but no class name after it all. This creates what's called an anonymous type. C# generates a brand new nameless type behind the scenes just for this exact combination of properties. So let's see if on the properties, for example, product name, maybe product.name, and then it's price, product dot price. Okay, as you can see, laptop $1,200, and we can access its properties completely normally, .name, .price, or .in stock, exactly like any regular object. And we can actually do with a link use also, but we need the class itself. Let me show you. For example, we're gonna have class product itself this time, equals new equal, or maybe public string name get set, and public integer, integer, yes, price get set, and then maybe public int stock get and set, right? And then here we're gonna have list of products equals new list of products, new product, name equals maybe lab, maybe mouse here, mouse, and then price equals 25, and then maybe stock equals 10, right? And stock maybe 5, price 25, 75, keyboard, okay, var summary equals products dot select p new p dot name, and then p dot price. Okay, and then you can have for each var as in summary console dot write line s dot name, and then $sign s dot price. Okay, so let's run this. As you can see, mouse is $25 and keyboard $75, right? This is genuinely where anonymous type shines most, combined with link use select function. Let's see here, transforming a full object into a smaller temporary shape containing just the pieces you actually need for a specific situation without ever needing to define a new dedicated class for it. Anonymous types are genuinely best for short-lived throwaway data shapes, especially inside the link queries where creating a full permanent class would be overkill for something you'll only use in one place, right? So next up, something genuinely powerful. What if you want to add new method onto a type you don't actually often, like string, which is built into C# itself? You obviously can't go edit a Microsoft source code. That's exactly what extension methods solve. Let me show you code. Static class, maybe string extensions. Okay, first the containing class needs to be static. Remember the static from the OP lesson. This class itself won't ever be instantiated. It just holds our extension method, and inside that we're gonna have public static bool is palindrome, and then this string text. And public static bool is palindrome. This is this string text, right? The two things to note here: it has to be static method, and that this keyword right before the parameter type is what actually makes it an extension method, specifically extending string. And here string reversed equals new string text dot reverse dot to array. Uh, Here, okay, and then return text dot to lower equal reverse, right? Reverse dot to lower, to be much more specific. Yes. Inside we reverse the text and then compare it to original, ignoring case genuinely, just checking if it reads the same forwards and backwards, right? And maybe we're gonna have example. Let's see here. We're gonna have string word, maybe race car, right? Word race car, bool result equals word dot is palindrome, console dot writeLine result. So let's see output true, right? And now look at this. Word dot is palindrome. Call it exactly like it was a real built-in method on string itself. Even though string is a type that we don't own and never modified directly, it now genuinely appears to have this brand new capability everywhere in our code, right? And here's the worst knowing part. This is exactly how LINQ works under the hood. Actually, genuinely satisfying connection back to something you already know. Remember .where, .select, all of LINQ from a few lessons ago, right? Every single one of those is built using exactly this mechanism extension methods added onto collection types, right? Now you know how that's actually possible because remember, whenever we get the lists and then maybe call, for example, look at here. We have integer and maybe r equals kind of 1 2 3, right? And then we're gonna say r dot sum. As you can see, we can access to sum method, right? And what if we just create a list, maybe int a equal 1 2 3 4, something like that. And then a dot sum. As you can see, we can access to sums. Why? Because sum also extension method, namely the static method, that is how can I say, that can be used with only collection types, because array also and list also get inheritance from a collection interface. That means they're gonna have some kind of features that iCollection interface have. Remember from the interface lessons that we covered, if I'm not mistaken, on OOP lessons. So extension method lets you add new functionality onto existing types, even ones you don't own, like C# built-in types using the exactly this parameter, this keyword parameter syntax inside a static class. Alright, next topic. You've actually already seen this scattered throughout this whole series without me fully explaining them. That are attributes. Let me show you code. For example, there's the obsolete use new method instead. I'm gonna explain what this kind of things. Void old method console dot writeLine. This is the old way. Okay. Square brackets and obsolete parentheses and message inside right above our method, right? This is an attribute. Attributes attach extra metadata to your code, information about the code, rather than the code's actual behavior. So let's call this function old method. Okay. As you can see, compiler is showing our warning here. Let's see, read the warning. Old method is obsolete. Use new method instead. You see that? And calling this method now, the compiler actually shows a warning right there. telling you this method is obsolete and suggesting the alternative genuinely useful for guiding other developers or future you away from outdated code. That's very useful. And another built-in attribute you may have seen is something like that. Let me show you. I think we're gonna use using system.text and JSON serialization class user DTO and JSON parameter name, and here we're gonna have full name public string name get and set equals empty string. Another common one, telling a JSON serializer that this is property name in our C# code should map to full name in the actual JSON data. Attributes like these are everywhere once you start working with frameworks and libraries. Now we can actually build on our custom attributes too for our own purpose. Let me show you. Class, maybe author attribute, and we get inheritance from attribute itself. Public string name get public author attributes string name equals name, right? A class attribute author attribute colon and attribute, we get inheritance from that, and notice the naming convention, it's called author attribute even though we'll actually use it as just author. That attribute suffix is a strong convention and C# actually lets you drop it when applying attributes. Let me show you. Here author and then maybe Alex. Oops, Alex, and class my feature. See that? Here's it in use, square brackets author, not author attribute here, and we are giving Alex right above a class. We are now attached custom metadata who wrote this directly onto our class definition. To summarize, attributes let you attach metadata to your code that tools, compilers, and libraries can read and act on. Built-in ones like the obsolete are genuinely useful day-to-day, and custom ones become powerful once you start building frameworks or working with more advanced C# features like the reflection lesson coming up soon or something like that. Okay, last topic for today, and this one's genuinely important for writing safe, resource-conscious code. Let's simulate opening a file. Maybe stream writer, and writer equals new stream writer, and then log.txt writer writer dot writeline hello file and writer dot close. We open a file for writing, write to it and close it. But here's a genuine risk. What if something throws an exception between opening and closing? I mean here, what if some kind of code crashes here and then we couldn't manage to close it, right? That close call never runs and the file stays locked open, potentially causing real problems elsewhere in your program. Remember the finally block from the exception handling lesson. We could drop this into try finally to guarantee cleanup, but C# actually gives us an even cleaner purpose-built tool for exact this kind of situation. Let me show you. It is using stream writer writer 2 equals new stream writer log.txt and then here writer 2 dot write line hello file. Okay, using parentheses stream writer and writer2 equals new stream writer, and they're giving log.txt closing parentheses, right? Then curly braces, and then using statement guarantees that writer2 gets properly closed and cleaned up automatically the moment we exit this block, whether it completes normally or an exception happens pathway, though no manual close call needed at all. It just kind of closes the file automatically. Okay, and also even much shorter version of that would be something kind of like that, using stream stream why it's not working stream writer, using stream writer writer 3 equals new stream writer, and then here log.txt. Okay, and then we're gonna say writer 3 dot write line and hello file. Okay, and this newer version, no parentheses, no separate block, just using right at the declaration. This cleans up automatically once we reach at the end of whatever methods or block we are currently in. Genuinely just a shorter way of writing the same guarantee. The using statement is your go-to whenever you are working with something that needs proper cleanups, files, database connections, network resources, guaranteeing that cleanup happens automatically even if something goes wrong. Alright, let's tie today's grab bag together with one connected example, right? Say we're gonna have kind of extension with static method, maybe static class list extension. Public static int min int max, and then we're gonna have get range maybe, and this list of our integer numbers, return numbers dot min numbers dot max. Okay, an extension method on list of integers, returning a named tuple combining two of today's topics right away, extension methods and tuples, right? And then we're gonna have one obsolete method, maybe using get range instead, and void old range method, and then it's gonna have some body. I think we need to put it before class, right, like that, and then gonna have list of integers scores, maybe new list integers, and then maybe 85, 92, 78, 95 maybe, and maybe 88, right? And then var min and max equals scores dot get range, and console dot write line range min to max. Oops. Min to max, and then var summary equals new count equal scores dot count, and then range equals mean minus max. Okay, console dot readline summary dot count scores and range summary dot range. Okay, we call our custom extension method and deconstruct the returned tuple immediately into mean and max values, and then build a quick anonymous type to summarize everything, count and range together for a final printout, right? So let's print this one. As you can see, range from 78 to 95, 5 scores range from 78 to 95, right? As you can see here, we used the extension methods, tuples, deconstructions, and anonymous types all working together, genuinely showing how these smaller features combine naturally in real code. So that's all for today's lesson. And for today's lesson, your challenge would be writing an extension method on string, call it word count, that returns an int representing how many words are in a string using split. Then write a method that returns a named tuple with word count and character count for a given string, and then deconstruct the result when calling it. Okay. So, summary of today's lesson is today we covered a genuine grab bag of useful features, creating tuples and giving their elements meaningful names, returning tuples from the methods and deconstructing them, anonymous types for quick throwaway data shapes, extension methods for adding functionality on the types you don't own, and also attributes both built-in and custom for attaching metadata to your code, and finish it with the using statements for guaranteed resource cleanup. None of these come up in every single program, but when you need them, they genuinely make your code cleaner and safer. Next time, we are covering modern C# features, some newer syntax additions that make everyday code even more concise. See you there. Take care.